How's it going, everyone? After my previous video discussing an order of operations math puzzle, I received a request to do a video on order of operations explained through examples from the game Dungeons and Dragons. To those unfamiliar with it, it is a game that involves a lot of dice rolling and hence a lot of calculations. So, let's get into it. Most of the calculations in the game do have to do with magical combat situations. So let's go. First rule of order of operations. You can add and subtract in any order. For example, let's say a warrior has 20 hit points and receives 8 damage, but is magically healed for 5 damage. How many hit points will they end up having as a result? Well, you could do this in any order. You could do 20 plus 5 minus 8, which will give you 25 minus 8, which is 17. Or you could do 20 minus 8 plus 5, which is 12 plus 5, which is also 17. As long as the 8 is subtracting and the 5 is adding to the total, you will end up with the right answer, 17, regardless of the order. Now, here's what you don't do. You don't do 8 plus 5 giving you 13 and then subtracting that from 20 and you end up with 7 hit points. That makes no sense anyways. You have 20 hit points, you lose 8 and gain 5. There's no way you're going to end up with 7. Here's the mistake. The 8 is subtracting and the 5 is adding. That's what they are supposed to do. If you combine the 8 and the 5 first and then subtract the result, well then you have both the 8 and the 5 subtracting because you're subtracting their total. That's not right. It is a positive 5. The 5 has to add to the total. The 8 has to subtract from the total. And as long as they both perform that task, you can add and subtract in any order. Moving on to rule 2. You can multiply and divide in any order. For example, let's say someone is hit with an arrow that does 6 piercing damage, but for whatever reason they happen to be resistant to piercing, so they only take half of that damage. So we have 6 divided by 2, but there are 3 such arrows that hit them. So we have 6 divided by 2 times 3. Well, as long as you divide by 2 and multiply by 3, you can do this in any order. So 6 divided by 2 is 3. Multiply that by 3, you get 9. Or multiply by 3 first. 6 times 3 gives you 18, and then divided by 2 gives you 9. Okay, so in one case you're seeing, well, one arrow will deal half of 6, so 3 damage. Multiply that by 3 arrows, and that's 9. In the second case, you're looking at as, well, it's 6 damage per arrow, and there's 3 arrows, so that's 18 damage. But because we're resistant to that, divided by 2, and we get 9. You can even do 6 times 3 divided by 2, and do the 3 divided by 2 first, and you get 6 times 1.5. Well, that's also equal to 9. That's like looking at it, well, we're being hit with arrows that do piercing damage, and we're being hit by 3 of them, but we're resistant to them, which cuts the damage in half, so that's like being hit by 1.5 arrows instead of being hit by 3 of them. It's a bit more imaginative, but the math is still correct. Moving on. Here's what you don't do. Don't do 2 times 3 first, giving you a 6, and then 6 divided by 6 gives you 1. That makes no sense. You're being hit by 3 arrows, each dealing 6 damage. You take half damage from each of those arrows, you're not receiving 1 damage. You're receiving way more than that. You're receiving 9 damage. What's the mistake here? Remember, the 2 has to be dividing and the 3 has to be multiplying. As long as they both perform those tasks, you get the right answer regardless of the order you do them in. But the mistake here is that we're dividing by 3 as well. Okay, we're combining the 2 and the 3 through multiplication and dividing by the result. That's like 6 divided by 2, which is 3, and then divided by 3, which is 1. That's not right. The 3 has to be multiplying and the 2 has to be dividing. Now, this is a common mistake because the way the question is written with these symbols for division and multiplication is misleading, and mathematicians, engineers, physicists do not use these symbols after high school, or they may even stop using them in high school. Here's a much better way of writing it down, using brackets for multiplication and a fraction form for division. 6 over 2 times 3. Now it becomes much more clear that you could do this in any order. You could do 6 over 2, which gives you 3, and then multiply by 3, which gets you 9. Or you can do 3 times 6 first, which gives you 18, and then divide by 2, and that gets you 9. Or you could do 3 divided by 2 first, and that's 1.5, and multiply that by 6, and that still gets you 9. Moving on. Rule 3. You have to multiply and divide before you add and subtract. For example, let's say you want to calculate how many hit points a character will have. And let's say they have 30 hit points from rolling dice plus a bonus. And a bonus is their constitution modifier multiplied by their level, which happens to be 3, their constitution modifier, times 5, which is their level. So 30 plus 3 times 5. Well, you do the 3 times 5 first, which is 15. 30 plus 15 is 45. They have 45 hit points. Reasonable for level 5. Now, here's what you don't do. Okay? You cannot do 30 plus 3 first. It makes no sense, right? The 3 is the constitution modifier that's multiplied by your level. Okay? If you do 30 plus 3 first, you get 33 times 5, which is 165. No, you don't have 165 hit points at level 5 if your constitution modifier is 3 and you were lucky enough to roll 30 on your dice. This makes no sense, right? This is a mistake. You have to multiply and divide before you add and subtract. And again, why this error can come about is because writing multiplication with an X is misleading. It's much better to write it with brackets. And if we have it as 30 plus 3 open bracket, close bracket, well then the 3 and the 5 look like they're one thing. And so people are more likely to treat it as one thing. Let's move on. Rule number 4, you must do exponents before multiplication, division, addition, and subtraction. Let's say you have to complete a task, which is pretty easy to do. The DC is 9, which means you have to roll a 20-sided dice and get 9 or higher. But you have advantage on this task, which means you roll 2 20-sided dice, and as long as at least one of them is 9 or higher, you have succeeded on the challenge. So, what is the probability of success? Well, it is 1 minus the probability of failure. What's the probability of failure? Well, to fail, you have to roll 8 or lower on the dice. And you have to do that twice, right? Because you have advantage. If one of the dice succeeds, you've succeeded, right? So you need 8 over 20 squared, which is 0.4 squared. That is the probability of failing. 1 minus that is the probability of success. Well, you have to square the 0.4 before you subtract it from 1. So here we have 0.4 squared is 0.16. We subtract that from 1 and we have 0.84 or 84%, which is pretty likely, as you would expect if the DC is 9 and you have advantage on the roll. Here's the wrong way to calculate it. If you subtract 0.4 from 1 first, and then you square the result, 1 minus 0.4 is 0.6. And when you square that, you get 0.36 or 36%, which is pretty unlikely. And that makes no sense. A DC of 9 and you have advantage, chances of success, 36%. That makes no sense. And that, of course, is the mistake, right? You have to do exponents before addition or subtraction. This is a bit of an imaginative example. Let's say your sorcerer is casting Ray of Frost, and it's using the Twinned Spell ability, which allows it to double the amount of creatures targeted. Okay, so normally it would deal 5 damage, say, with this Ray of Frost, but with Twinned Spell, now you have 2 rays, so you're dealing 5 times 2 damage. But let's say there's another sorcerer in your party who's using Twin Spell on your spell again, and let's say the DM is nice enough to say, well, each of the 2 Rays of Frost are being doubled. Okay, so now you have your damage multiplied by 2 again. And then let's say there's another sorcerer in your party who uses Twin Spell on your spell again, and again, each of those Rays of Frost that exist are doubled again. Okay, so we have 5 times 2 times 2 times 2, which is 5 times 2 to the power of 3. You've got 8 Rays of Frost coming from your sorcerer now. Okay, so if each one does 5 damage, 5 times 8 is 40. You've now done 40 damage in 1 turn, which is a lot, but that's reasonable because you spent a Twin Spell and 2 of your party members also spent a Twin Spell. That's pretty cool. But here's the wrong way to calculate it. If you were to do 5 times 2 first, you get 10, and then 10 to the power of 3 is 1,000. No, you're not dealing 1,000 damage from 8 Rays of Frost. That makes no sense, right? You have 1, you double it, you double each of those, you double each of those. 5 times 8, 40 damage, not 1,000. 1,000 makes no sense. The math is wrong. Moving on to rule number 5. You must complete the inside of brackets before anything else. That's the whole point of brackets, right? Brackets is a way to say, hey, whatever's inside, treat that as if it's one number. So let's say there's a warrior with a magical weapon, and when they attack, they deal 6 slashing damage plus 2 fire damage, and they attack twice. So what will the total damage be? Well, let's calculate the damage they deal from 1 hit, right? Do what's in brackets first. 6 plus 2 is 8. They've attacked twice, right? So 2 times 8 is 16. They will deal 16 damage. Here's the wrong way to do it. Multiplying 2 times 6 first and then adding the 2. Then you have 12 damage plus 2, which is 14. It's wrong and it's disadvantageous, and it also doesn't make sense, right? If each attack deals 6 slashing plus 2 fire, and you have 2 attacks, well then the slashing should be doubled, giving you 12, right? And the fire should also be damaged, giving you 4. 12 plus 4 is 16, right? So there's the mistake there. If you just do 2 times 6, you're not doubling the 2, and you're missing out on that extra bit of damage. Now, final challenge. This will use all of our rules. Let's say an evil sorceress has inflicted a curse onto the party's wizard. Each morning when the wizard wakes up, he receives 1 cold damage plus 2 psychic damage and 8 necrotic damage. Now the wizard happens to be resistant to necrotic damage, so that 8 damage is divided by 2. But when it comes to that psychic and necrotic damage, each day that goes by that this curse remains on the wizard, that damage doubles. Okay? Day after that, it doubles again. Day after that, it doubles again, and so on, until the wizard reaches some healer which lives far away who'll be able to lift the curse. Now, the party finds out that this healer lives so far away that it will take 5 days to travel there. And so that psychic plus necrotic damage is going to be doubled 5 times. And the party needs to know, okay, how much healing kind of material do we need to bring with us? So we need to know how much damage we expect this wizard to take in the morning, and the last morning is when he's going to take the most damage. So how do we calculate this? Well, we do what's in the brackets first. And in the brackets, we have addition and division, and we have to do division first. So we start with 8 divided by 2, and that gives us 4. So we have 1 plus, open bracket, 2 plus 4, close bracket, times 2 to the power of 5. Continuing with what's inside the brackets, 2 plus 4 gives us 6. So we have 1 plus 6 times 2 to the power of 5. Next after brackets is exponents. 2 to the power of 5 is 32. So we have 1 plus 6 times 32. Now we do our multiplication. 6 times 32 is 192. And finally, we add 1 and get 193. On day 5, our wizard will receive 193 damage upon waking up. So, good luck to them. So, I hope that clears up the order of operations, and especially in Dungeons & Dragons situations. I hope you enjoyed this fun little video, and until next time.